Hello, everyone. My name is Chris Berg. I'm here with Chip Bloch, and we're going to be your webinar host today. So hopefully everyone can hear me. Chip, can you hear me? So hopefully everyone can.
I can.
Let me walk through what we're going to do today. So I am your host, Chris Berg, CEO and head chef of DataKitchen. And Chip, do you want to say hello?
Sure, I'm Chip Bloch, Director of Data Engineering for DataKitchen.
All right, and so just some housekeeping before we go on. The slides and the recording, we'll send an email to y'all with them when we're done here. If you have any questions, just put them in the chat window, and I'll try to monitor it during it, but we may not get there, but we'll try to answer it at the end. So feel free to ask questions. So handouts and recording will be at the end. So what are we going to talk about today? We're going to talk about a new product, sort of that DataKitchen has called DataOps Test Gen, and we're going to try to put it in the context of what we call a data journey, and the failures in the data journey, and the 5 pillars of the data journey, and why DataOps Test Gen fits as one of those pillars. And then we're going to introduce the new product. We'll give a customer example because this product's been actually in use for well over a year, and Chip will do a quick demo, and then we'll answer some questions, or we'll answer it throughout. So going to the next slide. So we've talked about sort of why DataKitchen exists, or what's the problem with data and analytic teams. And I think a lot of times is that their projects fail, or that when they get something in production, no one trusts the data, or no one trusts the teams. They have too many errors. And we did a survey recently where teams are just stressed and unhappy. So if you look at the data on what data and analytic teams are doing, it's a very sort of unhappy state. Projects are failing, things are, people don't trust the data, and teams are stressed out. And so for us, the way that we've looked at the world is sort of opposite of a lot of people. We don't think the problem is that your database isn't too fast, or your ETL tool isn't easy enough to use. We think that there's a system that you need to build around your data and analytics estate. And the purpose of that system is to drive these 3 values, sort of lowering errors in production, increasing the cycle time at which you can get new things into production with low risk, and then just trying to automate various parts of your of the work that your data and analytic team does. And I think there's a lot of reasons why. We've written a lot about it, but I think just one of the reasons is, man, there is a lot of data tools out there. And Snowflake and Databricks are having their conference, and of course there's some new data tools out there. And so every day it's the sort of Cambrian explosion of data tools across everything: databases, data sources, ETL tools, visualization tools, governance tools, data science tools, AI tools. And so the way we think about it at DataKitchen is we want you to focus first on the data journey. So focus first on lowering the number of errors in production. And for us, errors, we use the term errors importantly because we think it's not just data quality. It's not how good your raw data is. That can be very important. But it's also all the other steps where it's raw data to integrated data to being used in a tool. And all those things need to be put together. And so for us, we've kind of boiled it down to something called a data journey. And I'm going to talk a little bit about the 5 pillars of the data journey. But the main problem is, errors are in a lot of places, right? They're not just in your data. And we're going to talk about testing your data today a lot. But in my experience, data problems are frequent and often, but they're also, you have report problems, or you have tool problems, or code problems. And so, reducing errors along that journey is very important for data teams. And if you do it, it actually gives you time to do more things. And so that path from data source to customer value, we call a data journey. And I'm just going to quickly go through these 5 pillars, mainly as context for what we talk about. So in this diagram, the red parts here are pretty typical. There's a bunch of data sources. Maybe there's a load process in here. Maybe there's a transform process. Maybe there's a predict process. Maybe there's a report process. There's your data, your infrastructure. And kind of functionally where these ideas go is we think the 5 pillars of data journey involve data at rest. And we're going to talk a lot about that today with TestGen, but also talks about data in use, and also talks about looking across all the steps that data takes and looking down all those steps, sort of down the stack, because problems aren't just in data. They could occasionally be in your server. And then setting expectations on all this so you know that it's right before your customer sees it. And so the first one is looking, the first pillar of a data journey is kind of looking across your steps and seeing if things are wrong in order. And sometimes you have tools that are a collection, they're unordered, or tables that are unordered. But a lot of times the data journeys have an order to them, right? You have to do your data work before you do your model work, before you do your viz work. And just making sure that that order happens, that SLAs are met, that timing's met, that there aren't delays, and really getting the process lineage and the process reliability right is the first pillar. And then the second pillar is, well, when things go wrong, they kind of go wrong in different places. A lot of times it's the data, but it could be, as I said, your server or your infrastructure or bad code or your network. It could be CPU, it could be disk space. And sort of monitoring those things in a very IT way is also important to do it. And that's just, is your tech stack working? And then the one that we're going to talk a lot about today is like, is your data right? Is its schema right? Is it fresh? Is it volume? Is it right from a business perspective? Like, have your sales gone up or gone down? Is the percentage that they've gone up or gone down? And that's really about what a lot of people call data quality. For us, we have a little more expanded because it's not just about the raw data, it's also about how you put the data together. And so we're going to talk about a tool to help automate the testing of data at rest, or the data quality validation testing of data at rest. And that's the purpose of our webinar. And the other part is that you have data that's not in a database, but it's in use. It's actually in a predictive model or in a visualization. And how do you test that? Because those are software tools that are driven by code that could have errors. And so how do you make sure the user experience is right with those tools? How do you make sure they trust the data? Even though the data in your database could be perfect, somebody in a model or a visualization could have mucked with it. It could be wrong, and your customer could find it wrong. And then sort of lastly, sort of the expectation layer, like you've got, your data journey should run with a certain CPU, your data, raw data and integrated data should be perfect. Your model should have this level of prediction. All these things have to happen in this order. And then how do you collect all those expectations and tell people and notify? And that's really about alerting and sharing that information. We've got 3 tools that focus on all the pillars of the data journey. We've got this new one right in the middle called Data Ops Test Gen, which I'm going to get to in a second, and Data Ops Automation, which focuses on data in use, and our Data Ops Observability tool. What we're going to talk about for the rest is this, how do you test data at rest in a database, as an example? And so how do you do that? And so, well, why? I guess the real question goes is sort of why? Like, why do we build a new product, and what's the problem that it solves? And so we've been doing data testing and talking about data ops for 7 to 10 years now. And so why? It's also why now. So what are the challenges with testing? I guess a lot of people have databases that are kind of black holes. They're dastardly dark databases. They don't really know what's in them. They don't understand it. They have a lot of tables. It's sort of a black box to them. And then data teams have a lot to do, right? Their customers are very demanding. Things are breaking. So teams are stressed out. And then obviously there are embarrassing production errors that your customers find, and they find them before you. And then data teams aren't able to kind of have the business knowledge. You may have 1,000 tables. How are you supposed to know all about the 1,000 tables? So if you're going to test data, how can you test data without really connecting the business and the levels in data and the syntax and semantics and pragmatics of data to put it together? So how do you actually, if you don't have time or the knowledge to create data validation tests? And so we purposely built these 2 things to solve those problems. And really it boils down to 2 things. One is that you're so overworked that you can't really trust the data or understand it, right? And then second is you don't have the sort of domain knowledge or time to fix it. And so these 2 big problems, I think, are very important in what we've tried to set out to solve, because fixing the ability for you to have to trust your data is really part of the data journey. It's not the whole journey, it's not everything, but it actually is important because data is combinatorial complex. There's a lot of, there's a lot of trust but verify that needs to happen in data. And so, I think helping data engineers understand the data, helping data engineers create tests against the data, and then helping them make sure that those tests are with what the business needs, and getting other people in the organization, like data stewards, involved are sort of the design points for it. And I'm just going to have a personal aside here. And so I'm going to talk about my own personal history here, and this is going to be funny. So like, why do we build it now? So I've been CEO of the company now for, I don't know, 9 or 10 years. And I've honestly been doing data testing since 2016. And I've always sort of written my own data tests. And, I'm a coder guy. So, but like, why was I sort of blind to those problems? And Chip is the one who actually help us as a company figure that out. Well, I reflected back on my experience in college. And when I was in college, I had a girlfriend, and she was sort of very musical, very artistic, and very sweet. And one day she couldn't get into her dorm room, and her doorknob was stuck. And she was frustrated. She tried for 10 minutes, she couldn't get it in. So she finally found me. I went up, and of course, me being the engineer who had taken everything apart that they could when I was a kid, I went and did left, right, boom, and the door opened, and it just made sense to me. And of course, being the sensitive guy I was at 20, I told her, "How can you not know how this doorknob works?" Almost laughing at her. And of course, she was mad at me for a week. And then even playing forward, when we started the company in 2014, I was a data engineer for a pharmaceutical company. It was a small company, had about 15 data sets, and I did the weekly data engineering, kind of using as a way to use our first tool. And for us, I was like, oh, I'm just going to do tests because I'm a software engineer. Software engineers write tests. And then, I think Chip is really kind of been the genesis of this, and he sort of has been building it in conjunction with a couple of customers over a bunch of years, and finally very gently said to me, Chris, this has really got value. We should make this into a product. So this whole slide is thank you, Chip. What do you think about that, Chip?
I like it. I'm going to remember this slide.
Well, it's the hardest thing about it. Sometimes your own blindness can lead you astray. And so I do think the real problem is it's really hard to write data tests. And that's what we're trying to take away. We're trying to automate it. So you can do more of the stuff that you like. And so what is our tool, right? So it's a tool that profiles data, automatically generates data tests, runs those data tests on data, and then shares the results pretty simply. So kind of breaking it down into buckets, and I'm going to go through each one of these. It has 28 simple, fast, automatically generated data quality checks. And I'm going to use the term data quality, data validation, data tests kind of interchangeably here, because there's not really a common word. And it does those because it has 51 characteristics that are done on profiling every table and column in the data. And it also has 11 sort of best practice business context fill in the blank data tests. And so, Chip and our team has been doing data tests for so long, we kind of see the pattern. And so there's a lot of cases where you can have a data test where you can sort of fill in the blank and say, okay, if you put in these parameters, you have a data test. And then after profiling, we have something called 13 bad data detector tests. So if you profile your data, you can start to understand what went wrong. And your data is your data, but you can actually start to look and possibly patch it or go back to your providers. So 28 automatically generated data tests, 11 sort of fill in the blank tests, 51 profiling characteristics, and 13 bad data tests. And so let's go through those. So what does it mean to automatically create a data test? Well, the way I think of it is data has both syntax and semantics, meaning. And so looking at the syntax of the data is done through profiling, right? Looking at, is a value present in a list of values? So you profile the data and find a column has 3 values in. And then next time you run this, you get a 4th value. That may be an error or may not be an error. You should know. And then there's another case. Did you get a date in the data that's incorrect? And so this idea, or is the schema of the data incorrect, or did it not, you get data not in the right format. So Chip's going to talk a lot about all the different checks that we have that are automatically generated, but the idea is, can you build this kind of quick scan of your data to find any problems, and then also be able to change it quickly so that you don't have too many false positives. So think of it as like an initial screening, or looking at every table and getting a test on every table. I think that's the first bucket. And so you're trying to make sure that your data is, when you get a refresh, that it's correct. And then another test is that, these are sort of business rules, and like, how do you know as a data engineer what the business is? Do you have a model of sales and marketing and manufacturing in your head? Very few data engineers do that. But like looking at trying to build these kinds of rules in to see if the total sales per region is the same week to week, or there's been a big increase. And the idea here is that your business customer looks at the world through a specific lens, and they've memorized values, and you're trying to find variations and problems before they do. And the idea behind this is that it's fill in the blank, right? You as a data engineer could put initial values, but then you can ship it off to your data stewards or business experts, and they can add it in. And so another sort of theme in this is, can you have the testing environment shared between you and your data stewards or your business customers? Can you maybe as a data engineer be responsible for running the tests, but can you get more people help you create and manage them as data changes? And then data profiling is very common. Like, there's a lot of data profiling tools out there, right? And think of it as an X-ray of your data, and looking at date characteristics, min-max values, numeric counts, percentiles, unique values. And so we have 51 of those that we use. And primarily it's to help you understand the data, but it's also as the basis to build those 28 tests. And then the 13 bad data detector tests. This is kind of looking at your data when you initially profile it and say, this data is just wrong. Like, you've got some null columns, but you've also got some columns that are spaces. That doesn't really make any sense. Or you've got leading spaces in data, or you've got invalid zip code formats, things where the data just looks wrong. And maybe you control it, maybe you don't, maybe you can give feedback to your customer, maybe you have to take the data as is, that's not your case. But like, whether it's feedback to your data provider, or whether you can patch the data, or whether you just have to live with it as is, it's really good to have this kind of initial screening to help you improve the data once you profiled it. And so these tools themselves actually fit, the data ops test gen fits within our product suite. So we have, for instance, our observabilities on the left that collects things on the run status and the logs and the schedules and the metrics and the test results. And we're just such a big believer in data testing that we've got a tool to help you generate tests. We've got to help you an automation tool that helps you write tests yourself. And then we have an open API that you can put in your existing tests or use some other tool. And all these things are important because testing, data validation, qualifying things, and finding out problems before your customer sees it is really essential for your team to move forward with data ops. And so it's been in development for 2 years. It's in use at several customers. We had the first commercial release this month. The results are visible in Data Ops Observatory. It's a SQL-based tool. So if it doesn't actually run on Python, it actually runs on different databases. And it's a table-driven SQL tool. So that the profile results, the configuration are all in tables that you can edit and change. And so right now the configuration is done by the CLI, but a UI is coming later in the end of the year. So think of it as a tool where the results are visible in Data Ops Observability. I'll show you it. It runs against databases, and because most data is in databases, and its configuration is done by a CLI, and a UI is upcoming. And so let me talk about a customer example. And so there's a pharma company that does this really amazing sort of cancer cell therapy drug where they take some of your blood, they look at it, and then they actually figure out from genetic tests what exact therapy you need, and then they give it back. It's incredible. And that data stream is not just used for analysis, actually used for like monitoring, reporting, and they effectively have 70 different data sources. And the people who use the data want data that they can trust, but they want the data as soon as possible, because like they're also using it to monitor the production process, right? If someone's blood got late, they want to know. And so the point here is that data ops test gen has been, and for a year and a half, actually doing the testing against this data, all these different data sets. And what that means is that the customers almost never find any errors. And it's not the only place that it does test. It does the data at rest test. There's also other places where data in use test is done. And it was done with a very small team. And so normal big pharma companies to say, build this whole system with reporting done in a year with 3.5 people, that would be crazy. I've seen teams that have literally 10 times that size and do less. And so by automating, by following data ops principles, by helping the team get time, by generating tests for them and configuring this for them, and also having the data stewards be involved, or the business owners be involved in configuring these tests, enable them to work really, really fast. And so another way to look at it is, there's just a bunch of different data sets that go in, and data ops test gen tested every step of the process. And so kind of going to the bottom here from, if you look at these columns, there's sort of data is posted in S3, it goes through a file daemon, a file processor, it goes through ingestion and data prep, it goes through some way to actually prepare the data, and then is actually put out to a Tableau dashboard. And at every step of the way, checking, getting alerts, and doing automated testing is helped by data ops test gen. And so there's another reason it's a very powerful way to make data teams productive, and the productivity comes from, writing tests is hard, and so it's a tool to help you write tests. It's a tool for you to help configure those tests with your business customer and data steward, and we're pretty excited about it. And so, Chip, how did I do? What do you think so far? Is this anything that I should add?
Sounds good to me. I think that the challenge here for data engineers is that we're the first line of defense for process issues, but we're often the last in line when it comes to knowing about the contents of data, and that's one of the challenges that we've been trying to address.
Yeah, and that's really tough. Like, first in line for problems, last in line to understand data. That's just like, that doesn't make sense, right? And that's part of the stress that teams have. And so trying to understand the full context at which data is used is hard. And so you can have this sort of layered approach, right, where these automatically generated tasks can be your first line of defense. And then your second line of defense can be these sort of configurable fill in the blank business rules, right? That's a second line. And then like even your third line of defense could be tests that are very specific to your type of company, or very specific to your business unit in your company, or the domain you work in. And so testing in drug discovery has very different needs than in manufacturing or than in financial services. And so this, thinking of it in 3 buckets: tests that can be written automatically based on syntax, there's sort of fill in the blank tests that can be based on semantics, and then there's sort of pragmatics, like tests that are very specific. Those are probably always going to be custom. And all 3 of those types of tests are needed in different places and at different times, depending. But giving you time to actually do that, both for data at rest and data in use, is what we're trying to do to help here. And so I'm going to talk about Chip's demo, and Chip's going to show you it. So he's going to actually fire up the command line and show you it, and I'll show you the results in data ops observability. So let's talk about kind of before you're producing data. So you get some data, and what Chip's going to do is profile the data. And when that profile runs, he's going to get a bunch of test results that identify bad data. And again, you could fix it, you could live with it, you could patch it. And then he's going to press something that auto-generates the data tests. And before data production, we also have another class of tests, this fill in the blank test. You could configure them. I don't think he's going to do that in the demo. And then during data production, the tests execute during production. And so you may have your ETL or orchestrator or cron job. It may be Airflow. It may be any number of tools that actually execute jobs. And then you're running these auto-generated data tests. And then you're actually perhaps running these business rule tests. And then the test results are stored in a database. And then they're actually can be sent off to data ops observability or anywhere. And so kind of that's the first two steps: before data production, during data production. But then there's kind of the case of after data production. And it's sort of like it's sort of tweak and improve, right? And so one case in improvement is kind of following the bottom here. You get new data. So your data in your database has changed. So you reprofile data and refresh the auto-generated tests based on the profiling. And this has to happen at some frequency. It doesn't have to happen every, it depends on the frequency of your data, how often it changes. Maybe it's every day, maybe it's every week for you. And then there's sort of tweaking the configuration of these tests, and he'll show you a YAML file, and there's a table representation too. And that's sort of data engineer refinement. But then there's like, how do you get other people who know more about the business in? Well, exporting the test definitions, right? And sending them to a data steward or a business expert. Now, we don't have a UI for that, and we're going to have a UI by the end of the year, but that's also part of the value here. And we've done this without a UI by sharing spreadsheets and sharing files, and that's actually worked just as pretty well. Maybe not every data steward would like it, but it works. It is workable. And then the data steward tweaks, oh, this test should alarm at 70 instead of 40. And then you take those improved test definitions and you put them in test gen, and they run again. So that's what he's going to walk through, the idea of before data production, during data production, and kind of after data production. And so Chip, I'm going to stop and share the screen. I'm going to make you the presenter and change presenter to Chip. All right, there you go.
Okay, great. So let's see here. How's that? Is my terminal window, red terminal window, visible?
It's beautiful. It's a nice sort of isn't it Harvard red? That's your color. Is that it?
You can see why we want a UI, but let's that's in the works. But let's take a look at what we can do here with the CLI. I think we've been able to do quite a bit. One thing that I really appreciate about having this as a tool is that we're able to share, we're talking about sharing information with data stewards, but what we're also doing is creating a feedback loop on a regular basis with both data stewards potentially and subject matter experts in the business, so that we're able to share responsibility and accountability for data quality, rather than play a game of hot potato. It becomes something that is everyone's responsibility together. So with that in mind, let's kind of move forward here. So first of all, I'm just going to grab an identifier. And what we're looking here is what we call a list of, oops, hold on. It is what we call a list of table groups, and a table group is basically a specification for a set of tables in one particular database. TestGen can work with multiple database connections, and that's a real advantage, because what we're able to do is to provide a kind of a consolidated hub for distributed data sets. In typical complex environments, you have different clusters and databases in different places. You may have data marts, you have self-serve environments. And what we're able to do is to consolidate a set of sets of rules and standards that can be applied to databases in multiple locations. So in this case, it's very simple. We have a little demo database on a Redshift cluster that consists of a couple of tables, but the tables are still big enough that it's a little bit awkward. So these are the tables we use for testing. We're using one table has 46,000 rows. Another table has 8,000 rows, and it's somewhat of an underpowered cluster, but we are able to just simply use some rules to specify which tables we're going to go after, and then we can run our profiling. I think in the interest of time, I'm not going to run the profiling here. Let me show you the profiling that we already have. It takes about 5 minutes to run profiling and to run testing. So I'm going to show you what we already have for those things, but let me show you here. So I'm going to something's pointed to the display. So these are multiple profiling runs that we have run in 2 tables, 184 columns. Now we can look at some details on profiling for each of these. We can spit out a whole bunch of details, but on screen, we'll only look at a few. So this, you can see here, this is providing some basic information. We have a whole bunch of different elements that we use, some of which are more useful for direct review, and some of which are more useful as inputs into the test generation process.
Oh, hey, Chip, could you just walk through a row here and sort of tell us what's in each column and sort of what it means roughly?
Sure. This is basically just each column in a table with the column name. We have something which we call general type, which basically is alphanumeric, date, or Boolean. We have the specific type as described in the database, and we have what we call a functional data type, which our system derives based on multiple sets of information, where we're trying to identify functionally what purpose the data type serves, and that allows us to, that provides input into our choice of which tests to apply to that column.
All right, great, thanks, Jim.
So now I'm going to show you the results of the profile screening process, which is basically that initial bad data check. It's that process to look for oddities of inputs that may be addressed as part of a data hygiene process. It's not necessarily something that you'd apply as a regular test in production, but it looks for potential issues that you might want to review as data hygiene concerns. And so here's some examples in our test data of some common tests, right? So we have cases where there may be a small number of blank values, and maybe this is a column where there shouldn't be any blank values. Similar to that, mostly one value, where we're looking for cases where, you know, why are there a very small number of divergent values? There are columns where no column value is present at all, which could indicate a problem. There are cases here where there are multiple depictions of blank values, where you might have some null values and some empty string values, and some of what we call filled values, which would be something like XXX or dash dash, or even the word missing or NA. You know, quite often in data sets, codes, let's say, that come from Excel, like an NA result, can make their way into data when we don't want to depict that as a value that's actually present. And then we look, among the other things we look for, and this is just some of the tests that happen to have been triggered by this data set, this test data set, but we also look for these pattern inconsistencies in data, where we boil down data sets into common patterns. This works really well to deal with things like data coming in from multiple sources, like phone numbers, for instance, that may come in formatted in different ways from different sources, and you can catch those formatting differences. Now, some of these may be nothing at all, and they may not be an issue at all, but this just alerts you to kinds of common issues that you can run into, and then you can make that decision about what is, what could indicate a problem. Other examples of things that we have, for example, I think Chris mentioned leading spaces. That's a common thing. Or importing data that somehow ends up with quotes in it. This will catch that as well. Then we get to the tests that are performed or that are generated in production, and what we can do is take that. Let's see here. Let's generate some tests here based on our profile. So we're going to use that table group. And we're going to create those tests in a what we call a test suite, which we're calling demo tests for this purpose. So we've just generated a bunch of tests. That was pretty easy, and now we can list them.
So you profile the test, you profile the data, and now you've generated, 28 different test types.
So,
wow, so there's 781 tests that you've generated.
781 tests on the two tables, 184 columns. So what we can do is, in practice, we run profiling on a weekly basis, and we periodically are able to refresh our tests. What this does is to refresh tests if they already exist with the latest values. You also have the ability to lock some tests from being refreshed. Let's say that you have tighter standards than are present, or different standards than the ones that are automatically generated. You can set your own standards as part of your test refinement process and tweaking process, and you can lock them so that they don't automatically get refreshed. But let's take a look at some of those tests here. So that's not really all that helpful. That's green because it's so wide. If I widen this, I don't know if people will see it. It's still pretty big, but there's a lot of information about the test. I think it might be better. Let me show you the YAML view instead.
That's just sort of like a printing of what's in the database, right? And so this is a way that puts it as like in a YAML file. That's easier to understand.
This is easier to read, and now the other view actually, anytime we pull data in the CLI, it's also creating a CSV file, so we're able to pull that into Excel and share it as an Excel spreadsheet. We also share them this way. It's a little bit more documented because different tests have different parameters and different sets of parameters, and this will show only the parameters that are associated with a given test. So as an example, there's for a particular column, the address column, there's a certain percentage of records that are unique, and we're testing for a shift in the percentage of unique records versus baseline data. So as you would imagine, these would be highly unique in an address column. And if for some reason they suddenly became less unique, there could be an indication of a data issue.
Yeah, and so what's good is this, both the CSV format and the YAML format could be shared with your business customers to be configured. The other part too is if you have separate development environments versus production environments. And some organizations are very strict about the separation. You can put this YAML file in Git, and then you can take it out of Git and then use that to run it in development. So you can almost like have an air-gapped environment, which some organizations have between the development environment and production. And you can build the test and build the test configuration, and see if it works, but then in production actually execute
it. That's right, and you can also have different versions of tests that you can generate into different test suites. So you can run a newer version experimentally and see how that goes. You can have a version that you retain that's in production, so that if you need approval for changing standards or changing expectations, then you can continue to run your original test suite as you test and gain approval for your new test suite. So there are all kinds of ways to do it. So now I'm going to go back to the other screen. And I'm not going to run test results. It takes about 5 minutes in this environment. But let me show you some test results that have been run previously. I'll do it this way. So these are some previous test runs. And what this shows you is for each test run, number of cables, the number of results, the tests that have failed, and whether or not the tests have been sent to observability. So in this case, most previously, this was actually last night that I ran this. In this case, previously, all the tests passed. That's really the way it should be when you first run tests based on profiling, because if it's the profiling that generates your tests, and then you're running tests on exactly the same data, you shouldn't get any errors. So I introduced one. I changed a data point, and I introduced an error on purpose. And let's take a look at how that error looks.
All this information for the test suite and the test time and the run is all stored in a database. And it can be shoved to observability. It could also be put to a governance tool. So for instance, I know tools like Atland and Alation have ways to augment their information about the data catalog and what do the rows and columns mean. And so we could push this to them as well. And so by having it persisted in a database, by having it configurable, by having it understandable, by having it tweakable, by maybe you have different versions of test config for development or not, it gives you a lot of flexibility to handle the change that's inherent that Chip talked about, the change in data or the change in requirements.
And we're also in the process of building our own dashboards and visualizations as part of our upcoming UI. So I think that's something that should be helpful as well. So looking at the test, we had a column called party status. There were only, I think, 2 or 3 different possible values at the time of profiling. Our test generation made the assumption that those values would be the only values that are present going forward. So we have a list of value match test. And then I changed a value, so it failed. And this provides that information. And it you can imagine in a case like this, it might be that it's totally legitimate that a new value is introduced, and it really isn't a data error at all. I want to point out that even if that's the case, this is still information that's important to share with downstream data consumers, because they may be building deliverables. I've seen deliverables such as dashboards and models that depend on an assumption of a certain number of potential values, and now for whatever reason that assumption has to be re-examined. So it's not just a matter of finding errors that are production failures, it's a matter of communicating with people up and down the data journey. You're in some cases, you may want to go back and contact upstream data providers and say something's incorrect here. In some cases, it's valid, and you want to contact downstream data consumers to say that there's been a change. And the tools here and the reporting capability provide a way to do that, or to track those changes.
So it depends on sort of your architecture pattern, right? Like, let's say you're getting 10 data sources. Well, it's obviously important to check those data sources when they arrive to make sure that there's any problems where row counts are less than you have, there's syntax errors, et cetera. And because you want that sort of the fresh, most perfect data that you use during production. And that's where you're sort of assembling the data and doing all the other pieces in the reports and dashboards and models. That's another use case. It could be on arrival, it could be in production. Some architectures have 2 or 3 database layers, layer 1, layer 2, layer 3. Sort of testing between those is also part of it. And then, as Chip said at the beginning, testing across databases. Maybe you have 4 or 5 databases where you want to profile and understand and check. And maybe that's like an offline activity that you want to help just understand the data system that you're in.
One area too where this can be very useful is looking at legacy pipelines and legacy tools where you're trying to provide an additional measure of oversight into the results of those tools. You may have to live with them for a while, but a common tool like this allows you to work with them and make sure that the end product of those tools is correct, regardless of what their processes are. So now let's export the information to our observability tool. And this basically exports everything that has not been exported so far for this test suite. And we're done. And Chris, do you want to show how things look, or I can show, however you prefer?
Oh yeah, why don't you show? Yeah, if you can show it, that would be great.
I've got it. So this is our observability tool. Let me refresh. What happened is by doing that export, we created a new instance of what we call our demo journey. Each set of tests comprises one instance, and you can see multiple sets of tests on the same data are available here. Let's dig into it. And we can see overall the status, 781 tests, 1 failed. And we can click in directly on the tests here. And this shows by default the one that failed that we saw here before. Now, this is actually our general test visualization that is usable for input from multiple testing products. One thing, as part of our UI, we're working on a more detailed view of our tests for our own product. But this is what this looks like. You can show all your tests if you want. And you can see all of our 781 tests.
That's great. Yeah, that's good. We've only got 5 minutes left, so let me take over, and I'll just close it out. So I think we've got we've got some actually really good, interesting things to read about TestGen. We got a white paper, a product overview. You can actually look at the documentation on our website to learn more about it. And of course, how the TestGen product fits in with the data journey and observability are also really, I think, really quite interesting. There's a document on the 5 pillars, the data journey manifesto. So we'll send these slides out, and we'll send the recording. And to kind of end with a commercial, our goal is really that you have more time to do what you like, because less customers are yelling at you and you're feeling less squeeze from your data providers. And so to do that, we believe that you need to observe the entire end-to-end data estate. And to do that, you actually need to generate data tests, because that's time consuming. And so why we built that product is to save you time. Now, there's a debate that Chip and I have. Will TestGen do 100% of your tests? And I don't think we have a debate. There's always going to be some custom tests. I think there may be more. I think it's really dependent. Maybe TestGen and its fill in the blank test and automated test can get 60, 70% of your data testing needs. Now, Chip sometimes says more, 90%. But I think the point is most people that I talk to have two. They maybe have a row count. Or maybe they're just seeing if and they're actually not testing their data at all. And that risk of hoping your data right is not a great strategy. And so if at all you can have tests, and that's why we built observability so open. So if you've already got existing tests, you can fit it in. And then sometimes you need to have tests that are built specifically for APIs and Pythons and languages. They're not data tests, they're more tool tests. And we've got a way to do that. And so I want to thank everyone today. We're just about out of time. And I see there's one or two questions, but we'll try to follow up by email. And thank you everyone for we're excited about this new product. It's available now. And thank you very much. Bye.
Thanks, everybody.